So when we talk about, we have here the following animation that shows the phenomena caused by presence and absence of air in pipeline. This is a diagram of an animation of a pump station. And we'll show the importance of using air valves in this system. So we have a complete system. Now it's gradually, the wet well is gradually filling up according to demand. According to, we have the float design. On our right, we can see the pump efficiency curve. And our curve right now, we're going to fill, this is a scenario, filling the system without air valve at all. So we're filling a system. We see that in that case, the pipeline is filled, but we have a very large restriction in the pipeline that leads to inefficient flow and larger head. That could be seen in the pump curve. Additional hazard is when we drain down the pipeline. If we don't allow air to be intaked, that causes the pipe to have negative force that could lead to complete suction of the pipe, or could lead to stress of negative stresses on the main water column. In addition, if we don't allow air in, the sewage line itself won't allow to be completely drained down, as we could see here. And if it's maintained for long, this could build up certain grease, fats, and residue on the undrained water column that could cause eventually some blockage. We're going to run the same condition, but now we're going to fill the system with proper air management using good, reliable air valves. So the same condition, the wet well fills up, and we're going to gradually fill up the system. In our case now, we've gradually discharged efficiently the air, and we see our pump curve have shifted to a much larger flow according to that initial restriction and lower head. So now in that initial case, we have a full system capacity efficiency. And now again, to prevent that negative pressure, we allow sufficient amounts of air to break that negative pressure.